there, Nick and Adam, who were there in the meeting as well. We are a small group. We've done lots of robots, more than one robot per person maybe. This is actually not the only robots kind of at each location. So these are a couple of big KUKA industrial robots on a linear stage. So the robotics lab has kind of traditionally worked across all the three verticals that Angie mentioned. So AEC, which is architecture, engineering, and construction, media and entertainment, and also D&M, which is design and management. Specify some kind of loading for what you want, and you want a lightweight with stiff gripper, stiff shape. So generative design, topology optimization is kind of a technique that's been used a lot. Some of the famous examples are airline seats, where you can get similar stiffness in the structure, but reduce the amount of material by a huge amount. You save a lot of fuel, and it adds up over the year. It's probably the most recent kind of wave in industrial arm robots. The interesting thing here, if you look closely here, is there's a tactile sensor. It's made by a Boston company called GelSight. And basically what it is it's like this gel-like material, and there's a camera on one side. So when it deforms, you can measure that deformation, and you can get both shape and force information as well. So, and this board is called a NIST task board. So NIST designed these boards for assembly tasks to do experiments with that. So we're looking at how can you do fine assembly. So say the kind of things you would see in electronics manufacturing or auto manufacturing. How can you do some of these things using robots like this? Where we prototype a lot of the small things.
Sachin, if you'd like, I can do a quick overview as we pass in the night. We also have an active resident team at Urban. So our shop has but I think we've been learning quite a bit, and it's become a very viable, usable tool for many of the projects that take place.
Engineer at Urban Machine. Max happened to be here printing a component for an end effector on our machine. And Max, maybe you want to talk about it for a couple minutes?
Yeah, so this was sort of a weird sort of design edge case where an off-the-shelf component wasn't going to work, and so I wanted to work on another part of the design at the time. So I used actually the
what you're able to see on top here is the hot wire deposition side, and then this is the machine side, which does both operations in one version.
The ability to modify or account for constraints for manufacturing. So you can see some non-traditional manufacturing methods in some of these artifacts. When this is an example of manufacturing constraints being applied. However, I've heard lots of different stories about how gnarly this was to actually do. We prototyped it here in San Francisco, and this was done in our Birmingham, UK Technology Center, which is a slightly different model. They don't support residents, exchanger of some sort. We've evolved, I mean, even our research focus areas have evolved over time. We used to have a little bit more in the health space, like there was a skull at one point, so potentially, surgical support, but predominantly right now we're in the product. In that this device here, the intention is to introduce new outlet types into the design and build of buildings, with the future of having plant life in places that can't easily be supported by human or maintained by humans. So that's one component, but the other component is they're really working alongside some heavy-duty data collection as it relates to the various species of plant life. They're collecting data both here with the soil in terms of water saturation and nutrients, but also in labs and getting a suite of data for machine learning about the various species and what they need. The bioserver is cool.